Hello and welcome to this video. In this video, we'll be looking into receiving APT data from weather satellites like NOAA 15, NOAA 18 and NOAA 19. The setup to do so can be seen on the screen. The NOAA satellites transmit APT data over certain frequencies. These signals are received by horizontal V dipole antenna. The choice of this antenna will be discussed a little later. The antenna is connected to RTL-SDR dongle, which in turn is connected to laptop via USB port. The first software that we are going to use is called HDSDR. It is a software-defined radio. The signals that are received in HDSDR are sent to another software which is called WXTOIMG. It is done so via a virtual audio cable. The WXTOIMG software decodes the data received into a weather image. We use a software called Orbitron, which is a satellite tracking software. This software tracks the movement of NOAA satellites 15, 18 and 19. The Orbitron software is connected to HDSDR using DDE drivers. The Orbitron software performs constant frequency correction of HDSDR software. This frequency correction is required to compensate for the changes in frequency occurring due to Doppler shift effect, since the NOAA satellites are traveling at a very high speed. We will look into each of these sections one by one. As stated earlier, we are using a V-dipole antenna in horizontal polarization. The reason for choosing this antenna can be seen in the article just above this figure on this particular link. Please visit this link and read the reasons for choosing this antenna. As you can see from the figure, it is a top-down perspective. The antenna consists of two elements. The length of each element is 53.4 centimeters. The angle between the two elements is 120 degrees. And it is recommended that this antenna should be oriented along the north-south axis. The first software we'll be downloading is called as Orbitron. It is a satellite tracking software. You can download Orbitron from the link given here. Please also download from the drivers section my DDE client 1.05 as shown here. It is a zip file. Extract the contents of this zip file into a folder. Please remember the location of the folder, which will be useful in the latter section. Once the Orbitron software is installed, we need to do certain setup for it to work. The first thing to do is go to the location tab and enter the details of your location. You may choose the nearest city to your QTH, or you can enter manually the details of your QTH in this section here. I have already filled the details of my QTH. Once you have filled the details, enter choose. You also have an option to add the location to this list. The next step is to go to the main section and enter into the setup. In this section, enter into TLE updater. Press the globe icon so that the TLE files are updated. Wait for the update to complete. Once the TLE update is completed, press OK. In the miscellaneous section, enter the value of 8 here. The reason for entering 8 will be explained in the later section. In the Extra tab, check the box which says AOS notification. This too will be explained in the later section. Press OK. The third step is to load TLE by pressing the Load TLE button. Here we are looking for weather satellites, and so we should select the TLE called weather.txt and press open. All the weather satellites are now loaded here. Select the weather satellites NOAA 15, 18 and 19. If you go to the rotor/radio tab, you can see the selected satellites. If you press show next, it shows the next satellite selected. The next important step is to enter the latest current frequencies of each of the satellites. For NOAA 15, the downlink should be 137.6200, which I have entered here. For NOAA 18, the downlink frequency should be 137.9125, which I have entered here. And for NOAA 19, it should be 137.1000, as I have entered here. Once you have entered all the correct frequencies, for each satellite, you should select My DDE. This is nothing but the DDE client we downloaded earlier in zip file. Once you press the run, it will ask you for the exe file which you have extracted in the folder. You should select that file. I have already done so, and so it runs the DDE client directly. The DDE status should be open. You should look into each satellite, and the DDE client should be running for each selected satellite. We have now completed the setup that is required for Orbitron software. Go to the website called as vb-audio.com and download a virtual audio cable from the link given here. Install this cable driver. This will help us to create a virtual audio channel between HDSDR and the WX2IMG software. Install the HDSDR software and get it running. We need to create a link between Orbitron software and HDSDR. To do that, go to the Options tab and select DDE to HDSDR. Select the Orbitron software here. Make sure that the status shows connection OK and press OK. We have now created a link between Orbitron and HDSDR. The Orbitron software will now be able to do frequency corrections in HDSDR, as can be seen here. Make sure that you have selected FM as the mode. Go to the bandwidth tab and select 48,000 as the bandwidth. Make sure that the FM bandwidth is 38,000. The NOAA satellite signal bandwidth is 34,000 and we have kept a little bit margin. So we have selected 38,000 as the FM bandwidth. Go to the SDR device, uncheck the tuner AGC and increase the tuner gain such that it is above 30 dB. Select the sound card tab and select the cable VB audio, that is the virtual audio cable that we installed earlier. Press OK. We have now completed the setup for HDSDR. For the WX2IMG software, go to this website and download and install the latest version that is available. Once the software is installed, we need to do certain settings to it for it to work. The first step that we need to do is to go to File and Update Couplers. Here you can see that the couplers are being updated. Once the couplers are updated, you need to go to the options and to ground station location. Here you need to fill the details of your location like we did in Orbitron software. The next step is to go to the recording options and at sound card select the cable output of the virtual audio cable that we installed earlier. The rest of the settings remain the same. If you remember, in Orbitron we had entered the AOS notification elevation angle as 8. Here too the default setting is 8, which means that this software will record when the satellite is above 8 degrees of elevation angle. The other setting here is 20. In the Heavens Above app, you can see that the maximum elevation attained by a particular satellite in its trajectory is given. This software will only record such satellites whose maximum elevation angle is 20 and above. So if in the Heavens Above app there is a satellite which mentions maximum elevation angle, for example, is 30, since the maximum elevation angle is above 20, that satellite would be recorded by this software. So when that satellite goes above 8 degree of elevation angle, this software will start recording. Once these settings are done, press OK. Now there are a few other things that need to be done. For example, uncheck resync if it is checked. Check show all if it is unchecked. In the file menu, go to the record and start a manual test. Here you can see that the manual test has started and the volume show is 33.1 and it is in yellow color. This needs to be in green color, which means that the level has to be at least 50. To increase the level, you need to go to the HDSDR software. Under SDR device, you can increase the gain and you can also try to increase the volume. This will increase the volume shown here. Ideally, the volume should be above 50 and the color should be green. Increasing the gain and increasing the volume can badly affect the image also if they are increased beyond the necessary limit. So you need to experiment a little bit and try and keep this volume at around 60 to 70 level. Also, you can take help from the help section here and check the calibration process, which gives you the important tips to adjusting the volume. Also, it gives you tips for sampling frequency, which will do a slant correction. Let us go to file and stop this manual test. Now we will go to file again and go to record and start the auto record. Now it is waiting for a certain satellite which will be available at 5:14 UTC time, and it also gives you a countdown that it will start recording after this time interval has elapsed. So now we have set the WX2IMG software for recording and decoding the data received from HDSDR. So here we can see a recording of a NOAA 15 pass over my location. I'm using a screen capturing utility here. The elevation angle is 6.8. So soon there will be a AOS notification given by Orbitron software, which you will see at the bottom of the screen, and the recording will start. Here you can see the AOS notification has been given, which means that the satellite has reached elevation angle of 8. You can see that the WX2IMG software has also started recording. The volume level is sufficient, although there was some problem with the gain and the volume level, which I will explain a bit later. Here you can see that it is recording the NOAA 15 pass. The elevation angle has reached 10.3. Still we are not getting sufficient signals, but we'll soon see that the signals will start gaining strength. The bandwidth kept is 34,000, which is the bandwidth of the signals that are received from NOAA 15 satellite. The elevation angle has reached 13. Here you can see that the FM bandwidth is 34,000. Here you can see that these signals have started appearing. Still they are very weak, but that means that the NOAA satellite is approaching the location very quickly. Here the elevation angle can be seen is 16. The image has started recording. Now I must say that this was recorded using a screen capturing utility, and I was not sure about the gain levels and the volume levels to keep. I was still in a learning process when I recorded this, so I made a few mistakes. Here you can see that the strength of the signals have started increasing. I'm increasing the bandwidth a little bit to accommodate the entire signal. I have kept the bandwidth right now at close to 46,500. I've kept a little bit of margin. Yes, so like I was saying that I was recording this using a screen capturing utility, and I was not sure about the gain and volume levels that are required. So I made a few mistakes in this. Here you can see that the image is a bit slanted. The reason for this is, since the screen capturing utility was running in the background, it was using certain resources and there was a mismatch in the sampling rate. Also, I had kept the gain and volume very high, and that resulted in losing some of the data. So we will not consider the image that is being captured right now as the final image, but we'll look into the process that happens. Here you can see that the NOAA 15 is fast approaching my locations and the signal strength is going high. The frequency correction is going on and the image is getting decoded. This is unprocessed image. The software will process the image after the recording is finished and it will show the final image. Right now here you can see the 32% of the image has been captured. The signal strength is going high. I'm again adjusting the bandwidth to adjust according to the received signal. The frequency correction is still going on. The Orbitron software is doing the frequency correction. So like I said, there were some lessons learned through this. There was another NOAA 15 pass the next day, and I did not use the screen capturing utility or any other applications or softwares. So there were no softwares running in the background, and the entire CPU was used for running these three softwares only. And that way I got a very nice recording, which I will show at the end of this particular recording. Right now the elevation angle is 70 and the signal strength has increased a lot. It is important to go to the help section in the WX2Img software and look at the calibration tips that are given. It gives the tip about the gain and volume control. It gives tips about the slant um, of the image, and how to set the sampling rate properly. It is important to keep antenna away from different structures at a height of at least 10 feet. And also it is important that none of the applications and softwares are running in the background. Considering all these points, you will get a very nice recording of the image. Later, in a day or so, I recorded another NOAA 15 pass, which was also an overhead pass with a maximum elevation angle of 80 degrees or so, with proper gain and volume settings. Also, I kept the antenna at a proper position, at a proper height, and I made sure that none of the applications and softwares were running in the background. By adjusting proper gain and volume, I was able to receive the entire data, so there was no loss of data. By keeping the antenna at correct position, there was no interference, and by ensuring that none of the applications, none of the other applications and software were running in the background, I made sure that the entire CPU was utilized for this process, and so there was no disturbance in the sampling rate, and so the image received was perfectly straight. I also use the calibration process which I mentioned earlier. So I highly recommend to read that calibration process given in the help section, which will help you to capture the data nicely. Right now we saw that the maximum strength of the signal was achieved, and now the signals are fading, which tells us that the elevation angle is decreasing now as NOAA 15 is going away from our location. 72% of the image capturing has been finished. So right now, since the elevation angle is decreasing, since the NOAA is going away from our location, the signals will go on fading, and the image will be fully captured. This is an unprocessed image which will be processed by the software, and the final image will be shown. I will cut here right now since the image is almost about to finish, and this image did not give the correct representation of what this process and what these softwares can achieve. So uh, I will cut here and show the next pass that I recorded in a proper way, which will give us the correct idea of how the image looks when it is unprocessed, and how it looks when a certain filters which are applicable for the NOAA satellites are applied to it. Here you can see that the elevation angle is dropping and NOAA is going away from the location. So shortly I will show the final image that I captured in the next pass. So this is the image that I captured of NOAA 15 pass after I learned some important lessons from previous recordings. So this image was captured by placing the antenna at correct position and at correct height. Also, I took help from the calibration process that is mentioned in this section. I did proper gain and volume control, and I made sure process was not interrupted by any other softwares or application running in the background. Help section also provides us how to take care of slanting of the image. I highly recommend to read this section, uh, which is very helpful, and it helped me to achieve a nicer image. Here you can see that the image captured, this is not processed with any filters. This is the image that was captured directly, and now we can go to the enhancements and apply any of these filters um, and extract the information that we require from the captured image. For example, you can do MSA multispectral analysis. So if I click this, you can see that the processing is going on, and these images, this data received will be combined to give a beautiful weather image of the location. Similarly, you can do a lot of different things, like for example, you can check the thermal image of the same location. It will process and show the thermal image. So there are a lot of things that can be done here, and you can experiment with the received image and extract whatever information you like from it. So I thank you all for watching this video. If you have not subscribed to my channel, please do subscribe, and also hit the notification bell so that you will come to know when I upload new videos. Also hit the like button if you have enjoyed this video. Thank you very much for watching.